So we're starting on 15, which should be exponential growth. There's nobody on.
They'll probably join us.
They will.
All right. So like I said, we're going to be on page 15, and we're going to be talking about exponential growth, exponential decay, and compound interest today. So the formula for exponential growth is going to be y equals a, in parentheses, 1 plus r to the t. Ethan.
What page is this?
This 15. So we have this equation. The way we know this is growth is we see the plus sign. Usually a plus means we're getting bigger. So something's going to be growing. Whatever we're doing the exponential growth for is going to be growing, getting bigger. So your A in this equation is going to be your initial amount. And your R is going to be your growth rate. And your T is going to be your time. Now, that R, one important thing to note about your R is that it is going to be in a decimal form. You're going to be given a percentage in the problems. Let's just say 7%. This has to be converted to a decimal in order to be able to use this formula correctly. So, can anyone tell me how you convert a percentage to a decimal? Close. That's how to get to a percentage. So, opposite.
Divide.
Yeah. So you can divide the percentage by 100. So you got 7 divided by 100, which will give you 0.07. Or you can just, let me scoot this up a little bit. You can just, because your decimal point will be right there, you can just move this 2 places to the left. So it would be right here. Either way works, and either way is fine. It just needs to be converted. If you're given a percentage with the percentage sign after it, you need to convert it. Because the formula will not work and you will get an incorrect number. So, looking at the first problem, let's identify our variables. So, we've got our A, which is our initial amount. So the first problem says the original value of an investment is $1,400 and the value increases by 9% each year. Use an exponential growth function to find the value of an investment after 25 years. So when you approach one of these word problems, what you're going to want to do is, if it helps you, it's going to be to underline stuff. So as I read this, the original value of an investment, okay, that's going to tell me what my initial amount's going to be. I can underline that. And the value, and I see that it increases, which tells me that I'm going to be using the exponential growth function. Then I'm given my percentage. And then I'm also given my time of 25 years. So we can start writing our variables out. Our initial amount, as it says there, is going to be 1,400. And then our growth rate, which is our R, is going to be 9%. Or what is 9% converted into a decimal? Yep. And then our time is 25 years. So now that we've got all our variables set, what we can do is plug them into our equation here. So we have y equals 1,400 in parentheses 1 plus our rate converted to a decimal, so 0.09 to the power of 25. And when you plug that into your calculator, what are you going to get?
Year 12,072.
And then, did you?
Like 3-1.
Yeah.
3192.
So the important thing to remember with money is if there is a decimal, you're rounding to the second place. So you round to 2 decimal places. So you said 12,000 what?
72.
72, and then what was your decimal?
0.312.
So 0.31, and then your 2 is less than 5, so you'll just stay. So it'll be 12,072.31. All right. Then looking at number 2, the cost of tuition at a college is $12,000, and it's increasing. I'm going to go ahead and box that in so it's different than everything else. At a rate of 6% each year. Use an exponential function to find the tuition cost after 4 years. So we're given all of our variables again. So our A is going to be 12,000 because that's our initial amount. Our R is 6%, which is converted to a decimal is. Yep. And our T is going to be 4 years. So we can plug that back into our equation. So Y equals
12,000.
12,000.
1 plus 0.06. The fourth power.
The 4th power.
And you get 15,149.72.
15,149 point what?
72.
Did everybody else get that? All right. So I am going to have you guys do number 3 and number 4 on your own, and then we'll come back and talk about them. I'm going to write it here. And just as a reminder, number 3 is talking about people, not money. So you can't really have part of a person. So if you round, and typically if you have any part of the decimal when you're talking about people, you just round up, just as a general rule of thumb. Just round up to the next whole number. Am I good to erase this and scroll up? Or does anybody still need this?
I just need Marissa's papers. Should be papers.
Did she even report to class?
She should change that.
Oh, then she doesn't have anything in. That's, is
I
that
have
yours?
something that we're giving out today,
Yeah.
though.
Maggie, is that yours? Okay. Then she has her papers for today, or she should anyway.
She's gonna be in my office for a while.
Okay. Jack, can you help?
No, I just have a question.
Oh.
When it says like 149,99, wouldn't you just put 150,000?
No, you need to keep this thing.
Okay.
Yeah. Okay. You don't know. This is what you wrote down? Yeah. Up there? And that's not what you got in the transfer.
So we're rounding up. Is it 447 something?
I know.
Okay, you should be able to type it.
Okay, so, classrooms, that's identification.
You don't have to turn anything in for that, you just have to watch the video, to do the notes
Okay, so.
on these pages. So the second half of the video is all of this, this we did in class.
Okay, and then, I do, like, date, like, date.
Okay, this is your problem.
I'm gonna go through everyone that hasn't been seeing assignments at the end of class and tell you what to see there.
So,
So just focus on what you're doing right now.
here. My husband had the same shoes. He made me buy them for him for his birthday. What's so special about
I
them?
don't know, I think.
He was like, they feel like house shoes.
Yeah, they do. Oh, okay. So
Right,
then
you, how you can't do that.
I don't think so.
Yeah, you can't have part of it now.
And does anybody have any questions?
Is the chat open on there? Because normally we'll just respond in the chat.
I've got the chat open.
Okay.
All right. I'll give you a couple more. Give you another minute and then. All righty. Can somebody tell me how to do number 3?
It'd be y equals 300,
Why?
parentheses, 1 plus, 0.08. And then, forgot what it's called, but put 5.
The power of 5.
Yeah, power of 5. And then it would equal to 441, when you round it.
All right. So everybody else get 441 people.
Mm-hmm.
All right. Can somebody else show me how to do 4?
You're supposed to do 4?
Yeah, I said 3 and 4.
Up there, right? I'll do it.
All right.
So it's y equals 149,999, and then parentheses 1 plus 0.06 plus parentheses to the power of 7,
All right.
and I got I don't know if that's a million or not. I'm not looking at it, but it's 225,543.
25,543.
0.03.
0.03. Did everybody else get that? All right. Now, does everybody understand exponential growth? How are we feeling about exponential growth?
Easy stuff.
All right. All righty. Let's move to the next page. And we'll look at exponential decay. All right, so if exponential growth meant that we had a plus sign in our formula, what do you think exponential decay is going to mean? Yep. So you're going to notice the formula is almost exactly the same, except that there's a subtraction in the parentheses. So it's y equals a, and then in parentheses, 1 minus r to the t. Your a will still be your initial amount. Your r is still going to be your rate. Or it'll be your decay rate, sorry. And your t is still going to be your time. Now, the way you tell whether or not you're using exponential growth or exponential decay is going to be the words that are in the problem. So if I tell you something's increasing or something is appreciating, what is that going to mean?
Is
Yep. And if I tell you something's decreasing or depreciating, yep. All right. So Looking at number 7, the population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Use an exponential function to find the population in 2008. So, first question, is this exponential growth or exponential decay? Okay, how do you know?
Because it says decreasing.
Yep. All right, so our A, we've got our A, our R, and our T that we need to figure out. So, what is our A?
Our A, 1300.
Yep. Now, our R is 1% per year, which what is 1% converted to a decimal?
0.01.
Yep. And then, what's going to be our time?
8 years.
Yep. All right. So we'll plug this into our formula again. So we've got y equals 1,300, 1 minus the rate of 0.01 to the 8th.
That's 10,296.
What did you get?
10,296. I don't think it's right.
What did you get?
1,199.57.
Okay, so then what do you do with it? Yeah.
Yeah.
Yeah, so you would round up to
I
1,200.
see what I did wrong.
So you would have 1,200 people. Does everybody understand why you would round up to 1,200? Yeah, you can't have part of a person. All right. So now let's look at 8. The value of a car is $18,000 and depreciating at a rate of 12% per year. Use an exponential function to find the value of the car after 10 years. So are we using growth or decay? Decay? Yep. Because it says depreciating. Depreciating means it's getting smaller. It's getting less, it's not holding as much value. So, what's our A going to be?
18,000.
Uh-huh. What's our R? So we have 12%, right? What is that converted over to a decimal?
0.12.
Yeah, 0.12. And what's our T?
10 years.
All right, so our formula is going to be y equals
18,000.
18,000.
Parentheses. 1 minus 0.112. Let's see, 10.
I got 501.3.
What did you get?
501.3.
I think somebody joined.
5,000.
5,000.
Yeah. 5,000.
Yeah, so you got, what did you get? Sorry,
Kayla Miller's on there.
5,013 and what?
Hey, Kayla.
0.01. Did everybody else get that? We all good? All right. I'm going to have you guys go ahead and do number 9 and number 11, and then we'll come back and talk about them.
That's the thing, now, it seems 8 or 6, 7, 8.
Do you guys have any questions?
Can I use the restroom?
Yeah, go ahead.
Finish the problems he asked and then.
Why is it
Am I okay to scroll up and erase these?
Yeah.
There, we got them copied down?
Oh, no.
We good?
That's 23,000. Oh, God. sexy. Wait, 9 and what?
9 and 11,
Why would we just do 9 and 10?
because I like 11 better.
Well, I said 10 alright.
That's okay. Here's more practice.
You want me to send this to your console?
Yeah, good stuff.
So, is that like 100 miles away? What?
Not that far. It's like a 30-minute drive.
I thought it was like in Arizona or something.
No.
Arizona's like 900 miles away. If you go to did you have all A's as a student in high school? The states are gonna say, Ohio State, Texas State, Ohio State.
University of Missouri.
Not yet, they're football. So,
As long as he's not working problems or if he does it, then we can.
Alright, oh, I did this
Page
one.
19 and 20 is gonna be-
I did this one with this.
And then page 21 through 22, we're doing those four problems.
Okay.
Wait, page. Oh, so it's just these ones?
All right. Can somebody tell me how to do 9? What's going to be your equation?
Y equals 50,000, that would be 19.10, power 7.
The what? The 7?
7.
And what did you get?
I got, 23,914.
914?
Yeah.
Do you have a decimal? Or
Yeah, 0.85.
0.85.
My calculator.
Did everybody else get that?
Yeah.
All right. Can somebody tell me how to do number 11?
So, I got Y equals 58, parentheses, 1 minus 0.07, the 8th power, and I got 32.45.
32.45?
Yep.
Did everybody else get 32.45? Or did you get 32.46? What was your decimal place for that?
I kind of,
It was like 5 and 5 and then
Oh,
oh yeah, 36.
Yeah, so the 5 would round up to 6. So the answer would be 32.46. All right. How are we feeling with decay? Good? Everybody good?
That's the lesson, so now we're going
You've got one more lesson. So everybody got this? Can I erase and scroll?
Yeah.
Wait, question, is the homework page 18?
No.
Dang it, do we have homework?
Yes, you have homework.
18 is one question,
All right. So now we're going to be on page 17.
19 is 5 questions. We only have 6 questions for homework?
That probably means we're wrong.
You've got more than 6.
It only, 18 is not.
Your homework's up here.
What, that's like.
It's not that bad, I promise.
That's
All right. So
It's 12 questions.
if you'll notice about the compound interest formula, it looks very similar to something we just talked about. Exponential growth and compound interest are very similar, except the fact that you have this new variable in. Right here and right there. So that n is just how many times it's compounded, which means how many times it's taken. So with this new variable does come some new vocabulary. If something's done annually, how many times is that usually in a year? Once every year. So your n is going to be equal to 1. Now, if something is done semi-annually, what does that mean?
0.5,
What'd you say?
0.5.
Well, sort of. How many times in one? How many times in a year?
Half.
2. Semi-annually,
Every half a year.
every half a year. You were right on the half. I was just.
Two.
So your n is going to be equal to 2 if it's semi-annually. If something happens quarterly, what is that going to mean? 4. Yep. Your n is going to be equal to 4. Now, if something happens monthly, what is that going to mean?
12.
Yep. N is equal to 12. If something happens weekly,
52.
52. Now, if something happens daily,
365.
yep. Okay. You will need to know these for the test. You just need to know what each of the vocabulary words means just to be able to use it in the problem. So looking at the first, and the only other difference in this formula is you've got P, which is your principal, which is still your initial amount. Principal is just a fancy word for it. So and the way you tell these problems apart from exponential growth is going to be when it says compounded. If it says compounded, you automatically know you're doing this formula. If it doesn't say compounded, you shouldn't be starting to do that. Because in order to do the compound interest, you have to know how many times it's compounded. So, looking at number 1, $1,000 is left in a bank savings account drawing 7% interest, compounded quarterly for 10 years. And you want to know what the balance of the savings account is at the end of the time. So, our variables, we've got our principal, which is our original amount, which is 1,000. Our rate, which is going to be 7%, or what is that converted to a decimal? 0.07. And then how many years? What's our T?
10.
All right, and then what's our N? What is it compounded?
4.
Quarterly. So what does that mean?
4.
Yep. So then we'll plug all of this into our formula. We've got A equals our principal, which is 1,000. 1 plus the rate, which is 0.07, over N, which is 4, to the power of N, which is 4 again, times T, which is 10. And when you plug that into your calculator, what are you going to get?
I just got an error.
So if you're getting an error on your calculator, the most important thing is when you plug this part in, you need to use the division symbol. If you use the fraction symbol, it's going to give you an error. So you'll need to put this in parentheses inside that.
Yeah, 1,071.86.
Did you put the 4 times 10 in parentheses too? That's the other thing is you need to make sure when you're putting this exponent in, if you don't just multiply it before you put it in.
10,000. Isn't it? 10,000.
So one of the most important things to do when you're doing these word problems is if you get the answer, you've just got to think to yourself, is this reasonable? Does this make sense for the context of this problem? Anybody else got?
2001.
So 2001, point what?
60. Oh.
Yep, 0.60. All right.
Sorry.
Now, we've got, let's look at number 2. This is the first one that we've done that's got a decimal point as the rate. It's no different from what we've already been doing. So again, let's go ahead and write, I'm going to go ahead and erase these just so I can write them in the same spot. All right, so our principal, what's our principal going to be?
750.
Uh-huh. What's our rate? We've got a 6.5%.
0.065.
Equals 0.065. What's our T? What's our time?
5 years.
5. And what's our N? Because it's annually. So we can plug this in. So we have A equals our principal, which is 750. In parentheses 1 plus the rate, which is 0.065 over 1, then 1 times 5, which is our time. And what are you going to get?
Person 27.
Did you have a decimal place in there?
Yeah, 0.56.
So 1,027.56. Does everybody else get 1,027.56? We have a different answer.
What should you?
What?
Oh.
Anybody else get a different answer? What'd you get?
3,983.75.
That's fine.
So, let's see. I would assume that's.
Who said they got that?
I don't know. Gabriel.
If you put in the calculator, in the exponent, if you put 1 times 5,
It'll only do the X, it'll only do this to the first.
You guys always need to calculate that exponent first and just do 5.
Yeah.
If you try doing a 1 times 5, it's gonna take it to the first power and then multiply the whole problem by 5.
Oh, I got it.
The only way to counteract that is to put the exponent in parentheses too. Did you get it?
Yeah, I figured that. I typed it wrong.
Is everybody good?
So like whenever, you can't use the fraction, but use the division sign.
What?
And then make sure you put 12 in your calculator for that.
I'm just confused how it works. So I did, said like 1 times 5.
You didn't do your
Do you guys have any questions? Or are you guys good?
What's the second to the right? Is that 62 or a 52?
You talking about right
The
here?
weekly.
No, like the rows, like.
Oh,
Oh, 50.
that's 52.
Okay, thank you.
Oh, this, okay. I just want to make sure you can use your calculator, okay?
What? I didn't do that.
Oh, that's fine. You just multiply it by 5. Yeah.
All right. Are we good? I'm gonna have you guys do number 3 and number 6.
Do you remember? Or do you want it?
Do number 3 and 6 on your own, and we'll come back in just a little bit.
So you're dividing by 5, but you should be dividing by n, and your n value on this one is annually equals 1. So you should be dividing this by 1. That should be a 1 right there. N is annually, so n is 1. Your exponent is n times t, and your t value is 5. So 1 times 5 is 5. And then you need to make sure you push your exponent key, and then 5. And then that should be the answer.
How do you get this?
From here, you look for this word in the problem. So this is annually, so n is 1. This is quarterly, so what's n going to be? Yeah.
Okay, so, yeah, it's only over 4, because up here it's 4 times 3, it's n times 3. Right?
So it's not divided by 12, it's only divided by 4.
So it's confusing with 3 years quarterly, so I have to put it in. Switch 4 and then 12. 12 times 4.
No, this is 12. It's the 3 years for it up here. So the 3 times the 4 up here, which is 12.
This one, this one.
The one thing, yeah, well, you are. So up here, it's 3 times 4.
Okay.
1, 3 times 4.
Right.
Did I do that?
So,
I didn't want this one as 90 because if it's money, then
yeah, so this is 31.
So you have to,
This one.
Did I?
What did you say?
oh, yeah.
Try putting it in again. See if you get it to 19.
That's the button.
You can finish 6 real quick.
6? Oh,
Oh. 31,706
Oh, that's probably. Oh, yeah, make sure we can put some problem.
What was the next one? Oh, shit. Is that 13 something? I deleted it.
Or just put 2 in that page.
I mean, you can't, we're gonna do that next problem, but it. Flip it around. That's about it.
Yeah.
All right. Am I good to erase this and scroll up? You good? All right. Go ahead and scroll up.
no, I said it's number 6.
All right. Here you go. All right. Go ahead and erase this.
3 years. Okay, the end is the number of times it happens per year.
All right. So when we're looking at 3, what's our principal? What's our P?
25,000.
Uh-huh. And what is our rate? What is it?
0.08
0.08.
And it's quarterly.
And T?
is,
And what is our N?
4%.
Yep. So what's our formula? We got A equals 25,000. Parentheses 1 plus our rate, which is over to the power of 4 times 3. So what did you guys get?
31,706.04.
6.04. Did everybody else get 31,706.04? All right. How about number 6? Can somebody tell me how they did number 6?
I did 10,000 plus, parentheses, 1 plus 0.16 over 52,
All right.
parentheses, power 104.
So how'd you get the 104?
I just multiplied the n and the,
Okay.
the sum.
So that would be 2 times 52, right? Which is 104. So what did you end up getting?
I got 13,764.51.
64 point what? 51?
Yeah.
Did everybody else get that? Did somebody get something different? Does this make sense? All right. If everybody's good with this, we can flip to that next page and we're going to look at this problem. This is going to be a problem you will see similar on your test and most likely on, I think you'll see that on the EOC too, right?
Yes.
You'll see this probably on the EOC too. So let me scroll down. Number 7. All right. So, Sam has inherited $10,000. He wants to invest his money and in his research turns up a few options. He's got option A, a 10-year government bond paying 4.5% APR. B, a savings account from a bank paying 0.5% APR compounded quarterly. And C, a high-risk mutual fund paying 8% APR compounded monthly. Now, first, let's figure out what equations we need to use for this problem. So, looking at A, what kind of formula, which formula are we going to use for that?
We're going to use the first one, exponential
Exponential, which one?
growth, upper A,
Uh-huh. Or do you say growth?
exponential growth,
Yeah. So why do we use exponential growth?
because it doesn't have an end. And says like how like it's compound interest.
And we're not losing money, so you know it's not going to be decay, right? All right. So now B, which formula are we going to use for that?
And the compound interest formula.
All right. Compound interest. And what are we going to use for C?
Compound.
Yep. Now, sometimes when you get problems like this, you are not going to be given your 10 years. You're not going to be given a time. Specifically for all of them, you're not going to be given a time. You may be given a time for one of them. The general rule of thumb would be to use that same time for all of them, because if you're going to compare them, you want to know which one's going to give you the most money in the same amount of time. So, starting with A, we know we're going to use the exponential growth formula. So our formula is y equals A to the 1 plus R to the T. So what's our formula going to look like?
It's gonna look. Yeah, it's gonna look like 10,000. Parentheses 1 plus 0.045. Parentheses power 10.
Yep. So what's that going to give you?
$1,552.97. Oh wait, never mind. I did it wrong.
So again, when you do these problems and you get an answer, you need to look, you think to yourself, is this reasonable? Because you know you're going to be growing. So did you say 1,000?
I actually got 15,529.
15,000, 15,000 what?
15,529.69.
You say 069 or 69?
0.69.
So you would,
Yeah.
Because what's the third decimal place?
It's 4.
So if it's 4, you'll stay. It'll stay 6-9. If that was 5, it would go up to 7. So you've got how much you're going to earn from A. Now with B, we said we're going to use the compound interest formula. So we've got A equals P to the 1 plus R over N to the N times T. So what's our formula going to look like?
10,000 of parentheses 1 plus 0.05 over 4 of parentheses 4 times 10 or just 40.
Yeah, I'm just going to write 4 times 10. Can somebody tell me what's wrong with this? You're close. You're really close.
Oh, it's 0.005.
There you go. All right. So what do you get from that?
Uh, 10,512.
10,512. Point what?
0.4.
Does everybody else get 10,512.40? Because it's money. Everybody else get that? All right. Now, see, again, we're going to do the same thing, same formula. So what's our formula going to look like?
It's gonna look like 10,000 parentheses 1 plus 0.08 over 12 parentheses 120 or 12 times 10.
Which is going to give you, what are you going to end up with?
Uh, 22,196.40.
So 22,000. You say 196?
Yeah.
Point what?
40.
All right. Did everybody else get 22,196.40? Okay. Now that we know how much each of these options is going to give him after 10 years, what investment should Sam pick if he plans on it? What'd you say?
C.
All right. What's the reasoning behind it?
Because more money.
Okay. So the trick to this question is there is no right or wrong answer. This is all based on reasoning. You can make a reasoning for any one of these. So can somebody give me a reason why you would pick A?
It's not as risky.
Yep. Can somebody give me a reason for B?
Quarterly. But, I don't know.
Why would Sam pick B over C?
Doesn't know.
So a savings account is traditionally very safe. You're not going to lose money with a savings account. Once you put it in there, it's there. Unless you take it out. And the other benefit to a savings account is you can take it out whenever you want. A government bond, you can't touch that money for 10 years or for however long the bond is. And then, like we said for C, it pays the most money. But why wouldn't you pick C?
Because it's a higher risk mutual fund.
Exactly. So you could lose money that way. You could lose it all that way. So now do you see why there's no right or wrong answer? It's just reasoning. All right. So your guys' homework is going to be 19 and pages 19 and 20, 1 through 8, and page 21 through 22, numbers 1, 4, 5, and 7. Now I do want to look at number 7 on page 22 with you guys real quick, because it is a little different.
What I'm supposed to do, 1, 2, 4.
1, 4, 5, and 7.
I already did one.
All right, let me scroll down to that number 7 real quick. All right, the reason number 7 is different from what we've been doing is because it says, so let's read the question. Your savings account has a balance of $2,513.45. You opened the account 3 years ago. Interest on the account is compounded weekly at an annual interest rate of 4.35%. And the question is asking, how much did you invest originally? So what are we actually trying to find? What variable are we trying to find with this?
What, how much money from the server?
Yes. So if we write out, so let's write out all of the variables we have for this formula. So we're using, which formula are we using?
We're using the compound interest.
All right. So we've got, our variables include capital A, P, R, T, and N. So let's look. Do we have a time, a specified time?
3 years ago.
Yep. Do we know our N?
N is monthly, so then 12, I mean, not weekly, so 52.
It would be, what'd you say?
52.
Yep. And do we know our rate?
0.0435.
Yep. All right, now we have our A and our P left over. What is the only other value we were given in the function, in the problem? What is that 2,513.45? Where is that gonna go? Yeah, it's gonna go to the A. So you got 2,513.45. All right, so let's write out our equation. So we've got 2,513.45 equals, we don't have a P, so we'll leave that there. Not equals. And parentheses, 1 plus, what's our rate?
Our rate is 0.0435.
435 over our N. What's our N?
52.
Yep. And then, so then we've got 52 times what? What's our time? 3. All right. So now you're going to want to solve for P. What I would suggest doing first, go ahead and multiply your exponent to get your whole number there. So what's that going to give us? We've got P 1 plus 0.0435 over 52. And 2,513.45. What's 52 times 3?
156.
What is it?
156.
156. All right. And now, what are we looking at inside the parentheses? If you go ahead and plug that into your calculator. So you could go ahead and plug all of this into your calculator, just don't mess, you just leave the P alone for now.
I got like 1.1.
So what if you plug in 1 plus 0.0435 divided by 52 to the 56th power? What do you guys get?
I got like 1.14.
Yeah, it's close. I think it's a rounding.
What?
Did you round?
Yeah, 1.14.
What was it before you rounded?
1.13.
What was the digit after the 3?
What?
What was the digit after the 3? It'd be a third digit.
1.
Right. So Okay, you're right. Sorry. I was thinking of the other one. Yes, you did 1.14. Yeah, sorry, you were right. I was thinking of the one.
I think when I worked it out, I did the whole thing in the rounding.
I think you did too.
Did I do it like exact answers?
So you got 1.14. And then 2,513.45. But how are you going to get the p by itself? What are you going to do? So if you're trying to get the p by itself, how do you move this over here? If this is p times 1.145, you divide. So I'm going to let you guys finish it from there. But yes, you divide. All right. And then the only other thing, I'm going to give you guys a minute, and then the only other thing I want to go through is we're going to go through your first page of homework problems. So 19 and 20. I'm going to have you tell me whether or not they're growth or decay. All right. Am I okay to erase this? Everybody got this written down? All right. All right. Let's look at the first one. Annual sales for a fast food restaurant are $650,000 and are increasing at a rate of 4% per year. Which function are we going to be using for this problem? What'd you say? Yep. We're going to be using the exponential growth. I'm just going to write growth. Now, number 2, the population of a town is 2,500 and is decreasing at a rate of 3.5% per year. Which formula are we going to use for that one? Decay. All right, number 3, Daniel's print shop purchased a new printer for $35,000. Each year it depreciates at a rate of 5%. What is this going to be? Yep. So, I'm going to ask you guys a question. If you had to explain this to somebody who wasn't familiar with the concept of exponential growth and decay, how would you tell them that number 1 is not an example of exponential decay? Because it has the word increasing in it. Exactly. And how do you know that number 2 and number 3 are both examples of decay? Because decreasing and depreciate both mean going down. All right. Number 4, the population of a school is 800 students and is increasing at a rate of 2% per year. What are we going to be using for that one?
Growth.
Yep.
I like when they participate, but
I know.
it always throws me off.
All right, I'm going to scroll down. So I think I can put them on the page. Oh, close. All right. Number 5. Kathy plans to purchase a car that depreciates at a rate of 12% per year. Which formula are we going to use for that one? Decay. 6, during a certain period of time, about 70 northern sea otters had an annual growth of 18%. What formula are we going to use for that one? Yep. Growth. And number 7, a population of fish starts at 8,000 and decreases by 6% each year. What formula are we going to use? Okay. And then number 8. 20 years ago, Mr. Davis purchased his home for $660,000. Since then, the value of the home has increased about 5% per year. Which formula are we going to use? Growth. There you go. All right. You guys are all set for that. I'm gonna go ahead and hand out these review guides. These are due next class, right?
Yeah, we'll finish them next class, but you guys need to work on them before that. This was the last lesson of this unit. So next class, we'll go over the questions that I didn't go over in that linear versus exponential video. We'll go over the review guide, and then you guys will take your test on Thursday. So we're done with